Hey guys, welcome back to the next video. In this video, we're going to see the Docker architecture or the container architecture. Docker is irrelevant. So if I say Docker, it's you can consider it as container architecture because it's Docker word is irrelevant because it's open source. So I can use any other tool rather than Docker. So we're kind of used to it. So that's why. So the understanding the Docker container or the generic container over here is that this is some architecture diagram which we have already seen. So you have the host operating system Linux, and on that we have installed Docker software. Now instead of just Docker software, we can install other container as well. In this example, we are using Docker, and through which we are actually creating containers. Now this architecture is not accurate. Okay, so it doesn't give you the property that it tells you that Docker is creating these containers and managing that. It's just not creating the containers or managing it. It is using the Linux kernel of this operating system to do that. So there's two important features of the Linux kernel which this Docker software is utilizing it. Now there's another architecture which gonna put in more details here, but then why I put this architecture right now here with this architecture is because I want to tell you that when I say Docker here and containerd here and then run C on the host system here, that doesn't mean that this is three different components and it is hosted anywhere else. It is all hosted together on a single host operating system. That is this one. So the Docker container software is actually running on the same system where the containerd will be installed and on the same system where the run C is installed. Okay. So please do not get confused in that term. Okay. So that's something I wanted to tell you to begin with. So the next thing I'm going to tell you is that look at this one right now. We'll focus this one. So there's something called open standards. First, let's talk about open standards. Open standards is when the Docker came into existence, every other major software company like Amazon, Google, Microsoft wanted to have their own container architecture. But then they decided that not to go for individual, but to go for something which is very common and can be used by multiple vendors like these companies and other people like me and you as well. So when they decided to do that, they come with something called open standards. Open standards meaning that the image which you're using, the containers which you're going to create, will all be portable. That's what we discussed earlier on the benefits of Docker is that it is portable container because the image which you're using, which you're building is all open source. Okay. So Red Hat Linux also contributes to this, but then you have to pay separately for the licensing part of it. There is even WebSphere containerization for that, but that also involves some costs. But these are, but OpenLiberty is there as alternative. Tomcat, TomEE, you have Apache HTTP Server, Nginx. So likewise, there are hundreds of other software which is going to be open source, which you can use it for free without paying any licensing fee to anyone. But then if you want the enterprise version of containers, that is also available for you. If you want to have a secure and some kind of a support from the vendor, so that is also available. I'm just telling you that. So both these options are available, so you don't have to really worry about that. But open standard is created in a way that this component, and this component can be portable, which means that you have alternative for this, you have alternative for this, you have alternative for this, you have alternative for this. Okay. Or rather than alternative, let's just say it can be portable somewhere else also, irrespective of what tool it is running. That's why. So this container can run with a different tool. This container can run with a different OCI or CRI. This container can run with Docker. I didn't tell you about OCI and CRI. Do not worry. I will cover that. So that gives you the flexibility and more mobility for your containers. And also it doesn't depend on one technology and you don't become slaves for that technology. So you have the reasoning and you can leave a specific technology any point of time if you want to leave. Okay, so that is the first thing I want you to understand in terms of Docker. So the Docker, and the further down the line that we are going to introduce, I'm going to introduce to other features of Docker, which is basically some things are missing over here, which I'll cover later. But then try to understand what information is over here at this moment. So OCI. Now OCI is Open Container Initiative. Now what is Open Container Initiative is that the activities of pulling images, building images at this level of OCI is done by the containerd. Now, is there a competitor for us? Yes, there is a competitor for containerd. You can use the new one, Cryo. Cryo is also something which is a option for your containerd. So it's basically created for OpenShift and Kubernetes. So it is most closely works with Kubernetes. So if you are thinking about having an orchestrator connecting with your container D, then you have to change your container D to Cryo and use that with Kubernetes and orchestrator. The CRI function of an particular this one over here, OCI. So there is a mixture function of this containerd. It can act as a CRI and as well as OCI. It's the same thing for Cryo as well. Cryo can act as a CRI and as well as OCI as well. So when you use some kind of a OCI, which is Open Container Initiative, you can use the Open Container images as well. Open Container images is what you find as an image in terms of your Docker Hub, wherein which you have a lot of images around that, right? Docker.io has a lot of images. So you can use all of those images because Docker-D is not using it. The containerd is actually utilizing that. Through the Docker-D, you are executing, here there will be a Docker command line interface, CLI, which uses the client commands like Docker pull, Docker build, Docker run. Likewise, you have the client commands which actually executed in the containerd. Okay, and there are certain activities which is done by this OCI. This is also OCI. We will see that on the next architecture. I'm not revealing that till then, but I'm just telling you, just giving you a heads up. There's another OCI in the lower level. So when you compare this containerd and runC, this is considered for high level task and connecting with the orchestrator because it has CRI. And this basically is the low level, it does the low level task. Okay, so what do you mean by low level task is that connecting with the containers using the namespace and grouping. Using that, it will connect with the containers. That is basically what your runC is going to do. Okay, so as of now, the high level task of image building, image pulling, and running those images will all be running over here, and the run command will be executed here. And runC is going to help, it's going to execute the will of whatever the command line interface, the client commands are going to say, and then it's going to be executed at the container level. So these are the actual process which happens within this Docker software in this host system. And then using, after all these internal process, it starts creating containers by containers. Okay. If you have any questions on this, leave it on the question section. So we will see on the internal workings of Docker on the next video. In that video, I will explain you more about the other functions and functionalities. I just want to tell you a quick heads up. So as an alternative to runC, you have these alternative like crun, runv, and then you have Cracker, Firecracker, containerd, gvisor, and then you have other options. So in Windows, it is notable to notice that instead of runC, we have runC HCS, which is used at the alternative rate for your runC. And runC means Universal Container Runtime. So that's what it is. So that's basically what I wanted to tell you before we close this session. Thanks again for watching this video. I'll see you on the next one.